now you might see something, well, actually, I might, yeah, I'm lying. You are going to see something like this. So if you look, it's the same exact function, but now you have these little numbers here. What are these? Well, before we took the antiderivative of this function over all x, every value of x. That's what that means. So those aren't exponents. This is saying, okay, now I want you to take the antiderivative, but I only care about what's between 2 and 0. So on the x-axis, actually, we'll flip it over. So we'll say between 0 and 2 on the x-axis. So this is x-axis here. This is x. I only care about what's happening between here and 1, 2, and here. So if we actually draw the graph, I'm going to show you what I mean by that. I actually drew it for you right here. So we know, so this red line, that is the graph of negative 2x plus 5. What's shaded in purple is that is your antiderivative, your integration. What you're doing, the integration is finding the area under the curve or the area under the line. And to prove that, we're going to find the antiderivative from 0 to 2. And we can do that on the calculator here. So on the calculator, if you press alpha, I can turn it on first, alpha, and then go to, you see y equals here, you see all these f1s, f2s, f3s, whatever. We want f2. And you see here number 4, fn integral, that means function integration. Press number 4. Ooh, look at that. So the starting point is always on the bottom, the end point is always on top. We usually say A, and that's B, from A to B. That's A, B, from A to B. So 0, that's where we start. We end at 2. A good way to remember this is Drake. Start at the bottom, now at the top. Negative 2x plus 5. And then again, we want to tell the calculator to find the antiderivative with respect to x because we have an x in our equation. X. Enter. Ooh, we get 6. What that's saying is from 0 to 2, the area under the curve is going to be 6. And you can check that on the graph here. And sometimes we'll be given problems like this, and they'll say, hey, what is that area under the graph? You either do it in the calculator like this, or use the graph. If sometimes they don't give you the equation, they'll just say, hey, find that area. Well, let's do this. To get the symbol, you do alpha, I think just window, alpha window, and the number 4. Like that. So now I said, okay, so from 0 to 2, our area was 6. That's what the calculator said. Let's check that. Well, I've got this shape here. That is a rectangle. And this rectangle is 3 by 1. So 3 times 1 equals 3. So then this is 3. That's the area right here, 3. And then let's see if we have another shape here. It's a square. Square is 1 by 1, 1 by 1. So the area here is going to be 1. That's 1. Then we have a triangle here. What is it? So in the calculator, we're writing a function and we're finding the antiderivative. I think you're getting confused about that. Yeah, so we're given a function. They're saying, okay, can we go backwards? Okay, so this is a triangle. So triangle is 1/2 base times height. The base here is 1. That's 1. There's 1. The height here is 1, 2. So height equals 2. 1/2 1 times 2. And that would be 1/2 times 2, which will give me 1. Let's use a different color. Let's say, so this is 1. This whole thing here, area equals 1. And if you look here, isn't this the same shape? the area here equals 1. So now we have 1 plus 1 plus 3 plus 1. I wonder what that equals. Plus 3 plus 1. So 1 plus 1, don't laugh at me, I need these. Plus 3 plus 1. Oh, we get 6. So then that's our proof. That shows us, okay, when we find the derivative, or the integral, we're finding the area under our line, or under our curve.